Bienvenidos, Husham and welcome Anne Arundel Community College learners from CTS-130, Section 402 from the Spring 2021 semester. This is the Cisco Networking Academy's Introduction to Networks version 7 or ITNv7 course curriculum. And in this packet tracer tutorial and activity, we're going to be taking a look at how to configure secure passwords as well as SSH. And so this is activity 16.4.6, and let's go ahead and dive in and take a look at the topology we're dealing with. Now, from a topological perspective, there's not much going on here. However, we've got quite a bit of work that we're going to be doing. Now, please be sure to note that there is a console rollover cable connected here between the PC and router A. And the first mistake learners will make is they will come to router A and they click on it and they see the physical view for router A. But when they click on the CLI tab, they get this message saying the CLI tab is locked, and they immediately think there's something wrong with the packet tracer activity. However, this is by design. This is the reason that our rollover cable exists between PCA and router A. Again, we have to be able to configure router A with an IP address and make it reachable before we could SSH to it and remotely manage it. And so the console cable connection here is going to facilitate that initial configuration of router A, and then we would be able to reach it and administer it remotely. So we have some information over here on the right-hand side. We have our addressing table, as we're very, very used to by this point. And you can see that switch 1 does have a switch virtual interface. In other words, it has that logical as opposed to physical, so it's a logical software run layer 3 address for VLAN 1. And we haven't covered VLANs in this course. They're going to come up in our next course, which is SRWE. However, remember, VLAN 1 is the default VLAN for all Cisco switches, and all ports on all of the switches are in VLAN 1 by default. So let's go ahead and let's dive in here with the instructions. So step 1, we're going to configure basic security on the router. Now, we've got some things we need to do first here. Let me leave the addressing table open here for a second. We're going to configure IP addressing on PCA according to the addressing table. So let's come to the desktop. Let's come to the IPconfig, and let's go ahead and enter in here 172.16.1.10. Now, you'll notice that by default, it automatically puts in what would be the classful subnet mask and dotted decimal notation for a 172.16. However, we are subnetting this down to a /24 to make it a little bit more appropriate. And the default gateway, as you can see, is quad zeros right now. Now, if we look over here, we can see PCA does require, or it's asking us to enter in that default gateway value. Now, be very careful here in understanding that, yes, we set the default gateway up to be router A. However, there really isn't a need for that right now because we don't have any other networks that we can get to. Remember, a VLAN is a broadcast domain, is a subnet. Remember that as we get ready to transition here in a few weeks into SRWE V7, the next course, Switching and Routing Wireless Essentials. And so we have a default gateway on PCA, and that's okay to put in there because maybe we're going to add to the network later, but we really don't need it since everybody here, the router, the switch, and the PC are all on the same network. So keep that in mind. All right. So now we're going to console into router A. And so here's why we have that rollover or console cable. I click on terminal, we click OK, And as you can see, now I'm on the router. So let's go from user exec mode with the enable command into privilege exec mode. And from here, we can finish the configuration of the router A. So we're going to get into the global config with the configure terminal or just conf t command. And we're going to put the host name here. So the host name is RTA. And then it says configure IP addressing on RTA and enable the interface. Well, router A, we have gigabit Ethernet 00 connected into the switch. And when I say no shut for no shutdown, you can see that we get the green up arrow there on router A. Now I could hit the fast forward arrows here and let spanning tree do its thing, but we've got some other work we need to do. So we'll let spanning tree, which is evidenced here by this orange dot, work itself out and go from the listening state to the learning state to the forwarding state, where we're going to get a green upward facing triangle there. So let's configure the IP address here on router A. And you can see the IP address configuration is very straightforward, 172.16.1.1. And again, remember that we are subnetting that 172.16 to a /24. So we'll go ahead and put the IP address on there. Now, we're going to exit out of, and before we do that, actually, it's not required here, but always a good idea, good best practice, is to put a description on this port. And let's go ahead and just say, and again, we're not getting points for this, but let's do something that would be of value here in an operational environment. So I'm going to say the description is PCA subnet 172.16.1.0/24, and maybe who configured it, and maybe the CCR number, the change control number, 8675309. And then someone who would come in might have an idea. Maybe you leave the company and someone's trying to figure out a couple years later, you know, who did this? What CCR was it part of? And they can go back and look and get some additional information as to why this was being done. All right. So let's get out of the interface config now. And now they're asking us to encrypt all plain text passwords. So right now, we don't have any plain text passwords. If I say do show run, you'll see that no plain text passwords are configured. We don't have a username configured or anything like that. So we'll go ahead and do this knowing that this is the right command. And that what we would see if it's a type 7 is we would see that Vignere cipher, which again is very, very easy to crack, but not for the wiliest of hackers, as we've commented, right? It's for your shoulder surfer. It's for that disgruntled employee who's looking to disrupt things, maybe. All right, so service password encryption, right? And that is going to encrypt all plain text passwords, which is if I was just to say username, Bob, password, ABC123, we'd have an issue there. Or I should say wouldn't have an issue, but that would be what would end up getting encrypted because it would be in plain text otherwise. Now, we're going to set the minimum password length to 10. Now, this is a command that is supported on routers. This is a command that you will not find with iOS on Cisco switches that are running iOS, right? So this is one of those commands when I first saw it, I was like, wow, this is a great command. I want to go put this on a switch, and the command is not there. So the command is simply security. Whoops, where are we at here? Let's make sure I get this right. Security. So security, passwords, minimum length, and you can see we can make it all the way to 16 characters, but we'll stick with 10. So security passwords, min length 10. And what this means is when I get ready to configure this user account that's coming up, we're going to have to put in a password of at least 10 characters. Now, it has a little note here, set a strong secret password of your choosing and choose a password that you'll remember, or else you'll need to reset this activity because you're going to lock yourself out. So we're going to make this very easy to remember. So it wants us to set a strong secret password. So enable, and we could say password, but we don't want that, right? We're going to say enable secret, and I'm going to say ABCDE 1, 2, 3, 4, 5, because that's 10 characters in length. Now, let's make sure here, and let's watch our completion percentage in the lower right-hand corner. Let's make sure that we get some points for this, because maybe they wanted us to say enable secret, or I'm sorry, enable password instead of enable secret. Nope, it was enable secret was what they were looking for. We got a few points. Now let's go ahead and say no IP domain lookup. Right? Always a good command to enter, because remember, what that is disabling on the router, and this command works on the switches as well, is that if from privilege exec mode I type a command in, but I mistype the command, iOS will by default interpret the typoed or mistyped command to be a host name and try to resolve that host name. And that's where you see that translating 255, 255, and then you're sitting there waiting if Control-Shift-6 doesn't break out. So no IP domain lookup prevents that from happening. Now we're going to set our domain name. Now the reason that we're doing this is we're laying the groundwork and the foundation here to configure our RSA keys for SSH use. So we'll say IP domain name CCNA.com. Now we're at 26%. Let's see if we get some points for this, because this activity is very similar to another activity that's in the CCNP ENCore version 8 course curriculum. And in that activity, it asks for the domain name to be ccna.com, but that value does not yield any points. So we're at 26%. And now we're at 29. So it does still work in this activity. Good news there. So now we're going to configure the username. So I'm going to say username, and you can see it says any user, so I'll just say admin, and then secret, and then any password. Well, I'm going to say ABC123. Now, you might be asking yourself, well, wait a second, what about that security passwords minimum length 10? Well, that's exactly why I'm typing this in, because I want to see that message right there. Password too short must be at least 10 characters. Password not configured. So we're going to come back and say ABCDE 1, 2, 3, 4, 5, just so it's something easy that we can remember here. And let's see if we go from 31%. And that's interesting. It actually gave us the points for that. But we also got the message telling us that the password was not configured. So we got points, but I wanted to show you that message there, password too short. Because remember, we've set the minimum password length to be 10 characters. So now we can go ahead and slide down here just a little bit. And we're going to generate some RSA keys. Now, these are the keys that are going to be used by the Secure Shell Protocol, SSH. And here's how we do that. We say crypto key generate RSA. Now, if I do a question mark, you'll notice I can say general keys and then put a modulus and then put whatever the modulus value that we were looking for, we could enter it in right here. However, the activity shows you to do this. It just shows you to say crypto key generate RSA. You hit enter, and you'll notice we see this message here. And this is why we need the domain name configured, because it's used in naming the keys. If the domain name is not configured, if you don't say IP domain name and enter a domain name in, you are not able to generate your RSA keys. So you can see the host name gets used and the domain name gets used as the name of the keys. And so here we would say 1024.1024. And then we're done with the key generation. Now, if I was to do this on a real Cisco router, and let's see if we've got the domain name set here on router number 9. So we'll say show run include domain. And let's see, no, so the domain name is not set. So what if I say crypto key generate RSA, and now notice on real Cisco iOS, I can jump right to the modulus. I don't have to say general keys and then modulus. I simply say modulus, and then I can put in the value I'm looking for. So we'll say 1024. Now watch what happens when the domain name is not configured. you're going to get an error message telling you, please define a domain name first. So I would say IP domain-name, and we'll say ccna.com. I hit enter. Now I rerun the command, and you can see that it generates the keys. And it was able to do that in 1 second. You can see right here the time elapsed was 1 second. Now, I'm going to do this on the activity as well, but I want to show you something very important here because I don't believe we saw this message over on the activity, or did we? And I'm looking here, and we did not see it. And I'm glad that we came here to a real Cisco router. So by default, and this is for legacy purposes, I'm sure at some point this will change, but for backwards compatibility legacy purposes, SSH enables on iOS by default version 1.9.9. This version of SSH is highly vulnerable to exploits and is easily exploited. You do not want to leave it at the default. And the version of SSH that you want to be running, whoops, sorry, IPSSH, I was saying version, typing version. So IPSSH version 2. That is the version of the protocol you want to be using. And so over here in our activity, let's go ahead and say IPSSH version. And you can see, and interestingly enough, right on cue when I hit the question mark there, it now comes up and says that. So I thought I'd seen this in the activity before, but we would want to be running version 2. Right now, we don't get any points for that, but keep in mind, that is what you would be doing in the real world. All right, so let's scroll down a little bit further here. And now let's go ahead and enter in some other configuration commands. So we're going to say login block 4 180 attempts 4 within 120. Now this is a little cryptic in terms of the command syntax, but what you're really saying is I'm going to block for 3 minutes anyone who in a 2-minute window tries to log in 4 times unsuccessfully. So if someone tries to log in 4 times unsuccessfully within 2 minutes, within a 2-minute window, I'm going to block that individual from logging in. I shouldn't say that individual. I'm blocking logins, period, for 180 seconds, right? And we're going to have a single user on here. Okay, so that takes care of that command. Now let's get our VTY lines ready to go. So line VTY 0 through 4. And again, if I say do show run, section, line VTY, you can see that we've got lines 0 through 15. So let's see if they're only interested. They say 0 through 4. Let's make sure that we get the points. And actually, we'll go ahead and say, I'm going to say line VTY 0 to 15. And let's see if we still get the points even if we do this. So transport input, and I'll do a question mark here. So this is for the virtual terminal lines. Which protocols are you going to allow to connect remotely to this router? And you can see we've got a few choices here. We've got all, meaning I don't care. I'm going to allow all protocols, whether it's Telnet or SSH, whatever the case may be, to connect remotely. None, meaning I'm locking the VTY lines down. No protocols are going to be allowed to remotely connect, or SSH or Telnet. Now, obviously, we don't want Telnet because the Telnet information is passed in the clear, including the password you're entering to get logged into the router. So we configured an SSH key, and this is why we were doing that, because we're going to say transport input SSH, and we do get the points, so that's good. And then we're going to say login local. Now, you guys have seen this command before. This is simply saying that if someone's trying to connect to the VTY lines, I'm going to authenticate them using the local user database. And that local user database is the username we created, right? So it's the local user database on this device, meaning we're not going out to a Radius server or a TACAC server trying to do authentication. We're authenticating right here with the username configured on this router. All right. So then we are going to go ahead and set the exec timeout. And what this means is, if I type this in here, you can see it's timeout in minutes. And so we're going to say, if you're not running any commands within a 6-minute time frame, right? Like let's say you get up to go get a cup of coffee, take a break. After 6 minutes of inactivity, of no activity, you will be logged off that VTY line. So we say exec timeout 6. Now this is also something that we could put on the console line. Now we're not being asked to do that here, so let's add logging synchronous as well. And let me go into line con 0, where I could say the same thing. We could say exec timeout, 6 minutes of inactivity, you're going to be logged out, and let's say logging synchronous. Right now we're not logging into the console port here, but I could say login local, and I would have to put in that username and password to get logged in. So let's go ahead and secure our console line as well. Again, not required, at least I hope it's not required here. I don't see that as being required. Okay, so I think we're good by what I just did there. I did make sure I don't break anything. All right, so we've added in some additional configuration. We're going to save our configuration now to NVRAM. So you can say copy running config to startup config. Remember, NVRAM is non-volatile, meaning the contents of NVRAM would be sustained through a reboot, right? Or a loss of power and powering on, which sort of implies that the box is going to get reloaded. So this command, copy running config, which is running in memory, in volatile memory. I want to copy all these changes I just made and save them to the startup configuration. And this is going to be done, again, in non-volatile memory. And so we go from 49, or we're actually at 49, to 51. So we did get some points. Now, another command you can use is write memory. That is synonymous with copy running config startup config. Now, not sure we would have gotten the points for that, which is why I held that command back until after we did the copy running -config startup -config. And on Cisco exams, my guess is you're going to get tested on copy running -config startup -config and not write memory. But no, in the real world, and typically I just do write mem, right, or wry mem. And I think you could even get away with just, WR, even though I just do wry mem. That's how it was shown to me initially, and sort of muscle memory, that's what I end up doing. All right, so back over here, we've saved the configuration. We're going to access the command line prompt on the desktop of the PC. So PC, and now remember, we're on the terminal here, so we're just going to close the terminal window. Now we're at the command prompt, and now we're going to run into the most common mistake that gets made in this activity. And there was a similar activity in the CCNA security course, and I would get questions on this immediately. And I'll show you exactly what I'm talking about. All right, so access the command prompt of desktop A to establish an SSH connection to router A. So if I say SSH /?, and that's what they're showing here, you can see we get packet tracer PCSSH, and then they show us the usage command. Now, is that a 1? Is that a minus, a -1, or is it a -L? And this is what causes all the confusion. So for users not familiar with SSH, we would say SSH, and I'm not going to tell you, is it an L or a 1, right? It's kind of tough to see, right? Well, that's a pretty clear 1, but the L could be confused to be the 1. So let's say SSH-1, and my username is admin, and the target is going to be 172.16.1.1. And you get this response back saying invalid command. So if you're getting invalid command, you use the -1. For the SSH command, it needs to be -L, admin 172.16.1.1. So it's got to be -L. Now we get that password prompt, right? So this is where we're trying to connect to a virtual terminal line, the VTY line. And it has a login local command. So ABCDE 1, 2, 3, 4, 5. Did I type that right? And there we go. we are now on router A. So we configured router A for remote access via the VTY lines using the username admin, and it completely works using SSH. Remember, it is -L. It is not -1 there. All right, so now we're going to configure basic security on the switch. So let's pull up switch 1 here. Let's go from user exec to privilege exec and then into global config. And we're at 51% right now, so this will be interesting to see if we get ourselves all the way to 100. So configure switch 1 with the corresponding security measures. Refer to the steps on the router. So now you're really going to be asked to do all of the configuration work we just did on the router. However, we're now doing it without the commands here. So if you need to look back, look back. I'm going to go back and get the IP address for switch 1, which is 1.2. And let's go ahead and dive in here. So host name is SW1. Configure IP addressing on switch 1 VLAN 1 and enable the interface. So this is our switch virtual interface, the SVI. This would allow access to the switch if we wanted to administer it remotely. So let's go into interface VLAN 1. I'm going to start out with no shut so we don't forget to bring it up. We're going to say IP address 172.16.1.2, and we know it's a /24, or in dotted decimal notation, 255.255.255.0. And so we get that sorted out right away. And then we're going to configure that default gateway address, right? Remember, the default gateway address, IP default gateway, and then the value 172.16.1.1. This does not mean, and I have to stress this again because this causes a lot of confusion with learners. When they see this statement here, they think, oh, well, if I put that on the switch, what that means is that packets that the PC sends here that come to the switch, because that's where the PC is connected, that it's the switch that is routing the traffic with that statement, that the switch says, oh yeah, send all that traffic up here. That's my default gateway. And that is not what is happening. Remember, the switch, just like the PC here, PCA, is a device, right? And the switch, we can generate traffic, right? Control plane traffic or management plane traffic. I can telnet from the switch. I can SSH from the switch. I can ping from the switch. I can trace route from the switch, just like I can do with PCA. And so all this statement is saying is that for traffic that the switch is generating itself, not transit traffic like PCA's traffic that comes through here, that's transit traffic. It's for traffic generated by the switch itself. This is the default gateway value that switch generated traffic will use. And if you think about how we configured PCA, it makes sense. When we did PCA, did we say, oh yeah, IP default, or I'm sorry, did we say default gateway 172.16.1.2 and send it to the switch? No, we didn't say that because we don't need to. All we need to do is send our traffic to the default gateway, who is the router. The traffic will transit through the switch to get there to router A. And that's why the default gateway value on PCA is 172.16.1.1. It's the router. And we see the router because we're all in the same subnet. We're all in the same network. We're in the same broadcast domain. Again, this command causes a lot of confusion. And I've seen this cause confusion with a lot of senior type network engineers as well, that they don't understand what that command does. It doesn't mean that switch 1 is now a layer 3 switch and is routing traffic for you. That is not what is happening with IP default gateway. So please keep that in mind. Very, very important point. So let's go ahead and move that out of the way. So IP default gateway 172.16.1.1, and that bumps us up a few points. And let's go ahead and disable all unused switch ports. Well, how can we see which ports are used and which ports aren't used? Yeah, I could say do show IP interface brief. And we can see that Fast Ethernet 01 is being used. We can see that Gig 01 is being used. Now, they show us this interface range command, and this can save you a lot of time. I can't tell you how many times I have learners complain, well, this activity is terrible because I have to go into every interface. Well, read ahead, take a look at the directions here, and it's going to help you. We're going to say interface range Fast Ethernet 02 to 24, comma, Gigabit Ethernet 02. And right now, I am in every single one of those ports at the exact same time. So any command I enter in right now, like shutdown, is going to affect all of the ports. And so you can see there, we just shut all the ports down, which is always a good idea that when they're not being used. All right, so now we're going to encrypt all plain text passwords. Well, we know that's our service password encryption. We're going to set a strong secret password of our choosing. Now, remember, if I say security, take a look. You'll notice that that min password length is not available. I can't even get there, right? Because on Cisco switches running iOS, you're not going to find that there. I would have loved had at some point they added that in to iOS, but they didn't for Cisco switches. All right, so strong secret password. So enable secret, and we'll say ABCDE 1, 2, 3, 4, 5. And we'll see if we get points for that being strong, and we did. All right, now we're going to disable DNS lookups, no IP domain dash lookup. And we're quickly closing in here. We're going to set the domain name to ccna.com. So IP domain name ccna.com, and we did the caps CCNA. And now that I'm saying that, I'm curious if I did that on the router. So let's reconnect up here. ABCDE 1, 2, 3, 4, 5. Oops, sorry. Yeah, so it should be ABCDE 1, 2, 3, 4, 5. There we go. We'll get into privilege exec, ABCDE 1, 2, 3, 4, 5. And let's say show run. Did I set the domain name properly? And I did. Okay, I saw the all caps for CCNA and I panicked there thinking maybe I did not set that up properly. All right, so IP domain name ccna.com, create a user of your choosing. So again, we'll keep it simple. Username admin. And are we going to say password? No, it wants a strong secret of ABCDE 1, 2, 3, 4, 5. And now we're going to generate crypto key generate RSA. We'll hit enter here in Packet Tracer. We'll put in 1024, which is the RSA key bit length. And let me hit enter, and there you go. Now you can see that it enabled version 199 by default. So let's say IPSSH version 2. Again, not part of the activity, but something you will definitely want to be doing. Now we're going to configure the all VTY lines for SSH access and use the local user database profiles for authentication. So do show run section line VTY, and you can see we've got 15 of them. So we'll say line VTY 0 to 15. We know we need to log in locally, and we only want to accept transport input SSH. The default is all, right? So you definitely want to come in here and make this SSH. So configure all lines for SSH, use the local user profiles for authentication. We did that. We're now at 94%. We're going to set the exec timeout here to 6 minutes on all VTY lines. That's going to take us to 97%, but why not pick up the console lines here as well, right? So let's go log in local, and let's say exec timeout 6. And we should probably go back and say logging synchronous to the VTY line. So we could simply drop back in here 0 to 15 and say logging synchronous. And remember that logging synchronous is going to make sure that if you've got log output that's coming to your screen, that it gives you your command line prompt back in clean shape. And so it's not all scrambled in there. All right, so we're at 97%, and I'm hoping here that when I say copy running config, startup config, that we get that last 3%, and we did, right? So we're at 100%, everything is ready to go. However, it doesn't ask us to test. Let's give it a test here. Let's see what happens. Let's log off router A, and let's say SSH -L admin 172.16.1.2, right? Again, we're not getting points for this, but hey, let's check this out to see, does it actually work? A, B, C, D, E, 1, 2, 3, 4, 5. And we are on switch 1. All right, well, that is going to do it for Packet Tracer Activity 16.4.6, configuring secure passwords and SSH. Again, we threw in some bells and whistles there that you're definitely going to want to be aware of when you're configuring SSH. All right, if you guys have any questions, let me know. If not, have a great weekend, and I hope to see you in the next video.